figures 11.3 through 11.5, overloaded stream insertion and stream extraction operators. Now, when you're building your own classes, one of the things that you want to do is make them as easy to use as possible for the so-called client code programmer, the person who's going to be using your class in actual code. Now, what we're going to do in this example is take a look at a use of a phone number class that we're going to define in a few moments. And basically what we want to do is allow the user of our phone number class to input a phone number object and output a phone number object just as easily as they can do with integers and doubles and the string class that's built into the C++ standard library, etc. So let's take a look at main first, and we'll actually execute this program in a moment as well. I just want to show you how we're using the phone number class. So we create a phone number object here at line 13. We then prompt the user to enter a phone number in a very specific form, and for simplicity we're not doing any error checking in this example, so we will expect the user to type this precisely as shown here with the parentheses, a space character, and also the dash in the phone number as well. The next thing we're going to do is input the entire phone number object. Now, C++ does not know your phone number class type in advance. It's not predefined. You have to define this class, or we had to define this class in this case. And because the cin object doesn't know what a phone number is, we have to define a function that represents this stream extraction operator, and that the compiler can then call to say this is how you read in a phone number object from the standard input stream. And you can see here in line 18 that we're actually showing you what that function call looks like, and as you'll see shortly, there is a function called operator double greater than sign, which is the function that represents the overloaded operator. And this function receives two parameters, one of which is the input stream object that we'll be reading the data from. This could be a standard input stream object, or as you'll learn after we talk about inheritance and polymorphism concepts, it could also be other types of input streams that are derived from the standard input stream type. The standard type is actually called basic underscore iStream. It is a class template type. There is a type definition for that called iStream, which just represents an input stream that can read characters. That's what the standard input stream is capable of doing. And for subtypes of basic underscore iStream, it is possible to have things, for example, that can read from a file. So I could use this same function to read from a file a phone number that is stored in that file. So the first argument is going to be the input stream that we're reading from. The second argument is going to be the phone number object into which we're reading the data. And we can actually write this function call into our code, but that would kind of defeat the purpose of having the overloaded operator function. The idea here is to make this class work like a built-in type, and therefore we write the expression cin double greater than sign phone to read data from the cin object into the phone object. Similarly, we can output a phone number object, so we display a line of text saying the phone number entered was, and then we output the phone number object using the same type of syntax that we've shown you over and over again for built-in types like int and double, and also for the C++ standard library class string as well. So here we're simply saying I want to output a phone number object, and again, C++ doesn't know how to do that. We have to tell it how to do that. So we'll be defining an overloaded operator double less than sign function that says how to use an output stream object to output a phone number object. And we'll take a look at the definitions of those functions in just a moment. Now, before we do that, let's go ahead and run the program just to show you that it works. So here again, we are expecting you to enter the phone number in the exact format specified. So let's say 888 in parentheses, a space, 555-5555, and when I press enter, you can see that it read that in, and then it was able to output the phone number object as well. Now, as far as you can tell just by looking at the output, what I might have done here is just read an entire line of text and then output that entire line of text, but as you'll see in a moment, I really am reading the 1, 2, 3, 4567890 portions of the phone number, storing them in separate pieces of data inside of a phone number object, and I really am outputting those 3 pieces of information when I display a phone number object using the overloaded output operator. So let's take a look now at our phone number class declaration. You can see here that class phone number has 3 pieces of private data that are string objects: the area code, which is the first 3 digits in parentheses, the exchange, which is the next 3 digits before the dash, and the line, which is the 4 digits after the dash in the phone number. We have no other member functions for this class. In this example, we're focused just on these 2 friend functions. And overloaded operators, depending on which operator we're talking about, are either going to be overloaded as member functions of the class or as non-member functions. And as you'll learn in a few minutes, the overloaded operators for input and output must be non-member functions of the class. They can't be overloaded as member functions. The reason for that is when you overload an operator function, if you overload a binary operator, such as the double less than or double greater than sign, that is an operator that has a left operand and a right operand. If you overload such an operator as a member function, the left operand is implicitly an object of the class that you're defining the overloaded operator function for. So if you look at the code here, you can see on the left side of these 2 operators, we have an object of type, we have the object cin or the object cout. Those are not phone number objects, and if we wanted to make these member functions of the phone number class, we would actually have to write these expressions in a way that's very strange. So we would say phone double greater than sign cin if this were a member function of the class, and that does not look right to anybody who's programming in C++, because they know when they're doing standard input that the standard input stream object is always going to be on the left of the operator. So because of the ordering of the operands around the operator in this class, we have to actually define these as non-member functions, number 1. And number 2, we are making them friends of the class because they are tightly coupled with the class. They are going to be operating on phone number objects. We, as the implementers of this class, are also the implementers of the overloaded operator functions for the class. And even though these are not member functions per se, they are so tightly coupled with the class that we're going to allow them to directly access the private data. Now, in this example, because I don't have any other public member functions, I have to make them friends. But if I had public set and get functions that allowed me to access all of the data, I could potentially make these just standalone functions that are not friends of the class. In general, overloaded operator functions that are not declared as member functions are typically declared as friend functions because they're so tightly coupled with the class and because they're implemented by the same person in general who implements the class definition. So let's take a look at our declarations for these 2 functions. You can see the operator keyword followed by the operator symbol. Now, when you're overloading operators, most of the operators in C++ can be overloaded, but there are a few that cannot. And for those that can be overloaded, if the operator is a symbol, like this case here, then you can append the symbol directly to the keyword operator. If the operator is a word, for example, if you're implementing a cast operator, you may need to use a word in that case. If the operator is a word, you must have a space between the operator keyword and the word that represents the cast operator. So here we have the operator double less than sign, which is the stream insertion operator. And here we have the operator double greater than sign, which is the stream extraction operator. And these are overloaded functions that represent how to do output of some type of object or input of some type of object, respectively. Now, the arguments are specified in the parentheses, the parameters, I should say. And as you can see in the case of the overloaded output operator, we're saying that we're going to receive a reference to an O stream. O stream is a name for the output stream object, a type name, I should say. And actually, it's specifically a type definition. Type def is a way of creating shorthand names for complex names. And as you can see here in the tooltip, the actual data type is basic underscore OStream. And the angle brackets that you see after that indicate that basic underscore OStream is what we call a class template. Now, class templates are beyond scope for the moment because we haven't introduced them yet. So we're using the built-in type definition OStream, which, as you can see here, is from the IOStream header file. The IOStream header file is where the definitions of the cin and cout objects are. It's also where the definitions of the classes that represent those objects are. And OStream is a shorthand name for the class definition for the output stream object cout, and iStream is a shorthand type definition for the class name that represents the type of the object cin. So basically what we're saying is that we can receive as an argument here the cout object by reference, and similarly we're also going to receive a constant phone number reference, and the reason we declared this const is because an output operator doesn't need to modify the data, it just needs access to the data. So it's going to receive a reference to a phone number that's considered constant. On the other hand, the input stream operator does need to be able to modify the phone number, so the phone number object that we receive by reference here is not declared with const, therefore we can modify it inside the function definition. And as you can see, the overloaded input stream operator is going to receive an iStream reference, and basically iStream is the data type of cin, so we can receive cin, or as you will see as you study C++ more, you can also receive any type of input stream that is a so-called subtype of iStream, and as you'll learn, that could involve a stream that represents a file on disk. It could represent a stream that is connected to a network and is receiving data across a network. It could represent a stream that's being read from a string object in memory. There's lots of different possibilities there. So the other thing I want to point out about these two overloaded operators is that each of them returns a reference to the same type as it receives as its first parameter. And this is important because if you want to be able to do things like chaining multiple outputs together, the result of the first expression in the chain has to be a reference to the cout object, in this case at line 25 in main. Otherwise, I can't then continue and output the endl stream manipulator. So it's very important when you're overloading operators to make sure that you have the right return data type. In the case of an overloaded output operator, it should typically return the same reference type that it receives as its first parameter, and the same thing for an overloaded input operator as well. So now let's go ahead and take a look at the actual implementations of these two overloaded operator functions. Of course, we include the phone number.h header file because that's not only where we define the class phone number, but it's also where we specify that these two functions are friends of the class, which is important because, as you're about to see, these two functions directly access the class's private data. Now, the overloaded output stream operator receives a reference to an output stream called output, and we're going to basically use that reference like we use cout because it's an alias for the cout object in our program, and our constant phone number reference, which we'll call number. So we're now going to use output like cout, and we're simply going to output a left parenthesis string followed by the phone number object's area code, and notice that we're directly accessing the private area code because this function is a friend of the class. Then we output a right parenthesis and a space, then we output the phone number object's exchange string, then a dash, and the phone number object's line string. So you can clearly see here that our overloaded output operator is outputting the three different pieces of the phone number object individually. And each of those, by the way, is a string object, and remember, this operator is defined in the standard library class string to specify how to output string objects, so we don't have to worry about that. Now, the other key piece here is the return of the first parameter by reference. Again, ostream ampersand is the return type, and line 16 is extremely important because that's what enables, the main function to chain outputs together here. So when I execute cout double less than sign phone, first it outputs the phone number, then the value of this highlighted piece of code is the cout object, or a reference to it rather, which can then be used with the next operator in the chain to output the endl stream manipulator. Similarly, we have our input operator, and again, we don't do any error checking here, so we expect you to implement this very precisely. Here we receive an iStream reference, which we're going to call input and which we're going to use like we use cin. We're also receiving a phone number reference called number, which represents the object into which we will place the data. Now, at line 24, we introduce the input object's ignore member function. Cin, which is what the input object refers to in this program, but it could also refer to other types of input streams, has a member function called ignore, and the version that takes no arguments simply says to skip one character in the input stream. Now, you remember when we ran this program that we typed in the phone number in a precise manner, as shown here, and we want to skip this character left parenthesis when we're reading in the parts of the phone number. So the input.ignore says to skip that first character, and again we're assuming that character's there, so this is important. Then at line 25 we use the input operator with the setWidth stream manipulator, which we've never done before. When you apply setW to an input stream, it says that you're going to read that number of characters from the input stream into the next piece of data. So setW3 says read 3 characters, and we're going to read those into the number.areacode member of the phone number object. Then we're going to ignore the next 2 characters, and again, if you take a look at our output window here, the next 2 characters are going to be the right parenthesis and the space before the next 3 digits. Then we read the next 3 digits into the exchange. Then we ignore the dash, and again, that's after the exchange. And then we read the next 4 digits into the line string of the phone number object. And now we've read the 3 pieces of the phone number. By the way, the ignored characters are simply thrown away. And finally, at line 30, we return input because we want to be able, if we wish, to chain multiple inputs together. So, for example, if I had an integer called x and I wanted to also read that in, I could write an expression like cin gives a value to phone number, then it gives a value to x, and that will allow us to chain multiple inputs together. So, as you've seen in this example, we have this capability of overloading operators so that they work with the new types that you create in C++, so you can create these new classes and make them easier to use for the client code programmer. And a key issue in this particular example, actually 2 key issues. One was the fact that an overloaded operator function can sometimes be a non-member of the class. Those typically are declared as friends, which we saw here in the phone number header file. And then separately, the overloaded input and output operators specifically must be defined as non-member functions because for a binary operator, that allows you to specify the order of the operands left to right around the operator. And again, when it's a member function that you use to overload an operator, the left-hand operand has to be an object of your class. And in these cases, we don't want the left-hand operand to be an operator of our class. We want the left-hand operand to be either the cin or the cout object respectively, and by making these functions non-members, we get to choose the order of the operators. And we'll talk more about that concept as we proceed through several other examples of operator overloading.